When we multiply decimals, basically one of the things we do is we use the same principle that we would use with multiplying whole numbers, except now we have to account for the decimal points. And so your book goes on to explain briefly in the beginning, taking 7/10ths and 8/100ths and writing them out and then multiplying them together. So that was the beginning of what your book did there. I'm going to take a problem here and use it as an example. I'm going to use 2.6 and 8.2. So with 2.6 and 8.2, basically the key is that you ask yourself, how many times do I have to move to the right after the decimal to get to the end of that number? Here we only move one place, right? There's only one place. These are the tenths. Both of these are in the tenths place. So you have 26 over 10 times 82 over 10. So if I ask you to multiply 2.6 times 8.2, you basically say 26 over 10 times 82 over 10. And then you multiply 26 times 82, right? You can multiply it out, 82, 26. You can do your multiplication, which we've talked about earlier in the book. You will get 2,132. You divide that by 100, right? Because 10 times 10 is 100. Now you have 2,132 and divided by 100. You move the decimal place twice to the left, 21.32. That will be the answer to that particular problem. So basically, what you do is you multiply the numbers without the decimal points, and then you apply that the decimal point correction, if we want to call it that. Your book gives you example after example of that principle. Let's look at another example. 1.86 and 9.5. So 1.86 could be written as 186 over 100, right? Because it is in the 6 is in the hundredths place. The last digit there, we look at what the place value is. And then 9.5 can be written as 95 over 10. So you have 186 over 100 times 95 over 10. And remember, when you're multiplying, you don't need to have a common denominator. So we have 186 times 95, which is 17,670 divided by 1,000. So now you move the decimal place, or you move 3 places to the left, and you have 17.670. So that would be the answer to that problem. Very good. So when we multiply decimals, that is one principle to keep in mind. We make sure that we multiply the numbers like we're multiplying regular numbers, and we apply the decimal place correction or how many places it needs to be in order to provide a final answer. So here's another example: 5.98 times 3.7. If these two numbers are multiplying, we could technically write it as 598 over 100 times 37 over 10. If you have any questions on how I'm getting these numbers in the denominator, the key to remember is what is the place value of the last digit in question? And then that corresponds to what is going in the numerator. So when it's a tenths, you have 1 over 10. When it's a hundredths, you have 1 over 100. When it's a thousandths, you have 1 over 1,000, right? So that's what's dictating the numbers in the denominator. So now we have 598 divided by 100 times 37 divided by 10. So we have 598 times 37. We have 22,126 divided by 1,000. That is very important there, because now we're going to apply the 3, right? There's 3 zeros in the denominator. So we go 1, 2, 3. So 22.126. That would be the answer to that particular problem. So you multiply them like regular multiplication, and then you move the decimal points over. If you have any questions on that, let me know. But that's the principle you're using. As far as signs, when you're dealing with positive and negative numbers, if you have a positive, 2.5 times a negative 2.5 or something like that, the principle is still the same. Positive times negative is going to be negative. Negative times negative is going to be positive. Positive times positive is going to be positive. And negative times positive is negative. So basically, whenever you have a negative and a positive, and in coming together, so positive times a negative or negative times a positive, your answer will be negative, right? But if the signs are the same, notice that they're the same. If you have the same signs, then your answer is positive. So keep that in mind when you're working with these with positives and negatives. So if you have a problem like this, negative 3.86 times negative 5.77, we know the answer is going to be a positive at the end, right? We know that's going to be positive. How do we know that? Because the negatives, negative times the negative is a positive. And the rest of the problem is basically 3.86 times 5.77. We can write the 3.86 as 386 over 100. And 5.77 can be written as 577 over 100 as well. So you multiply those together. If you want extra practice with multiplication, feel free to do the multiplication like that, right? And then you divide by, what are you going to have in the denominator? 1, 2, 3, 4. Why? Because this is 100 times 100. So you would have 4 zeros. Here's an interesting thing about multiplying by multiples of 10. If I say, let's see, if I have 10 squared, let me write this as a squared. 10 squared, that's 100, right? If I have 100 times 100, all I do is take these digits, or let's say 100 times 1,000. You take these 3 zeros here, and you apply them to that 100. If it was 2 times 1,000, that's just 2,000. You take the zeros and you put them at the end of the number in question. So that's the beauty of multiplying by multiples of 10. So 386 times 577 is 222,722. Now we have 4 zeros, so 1, 2, 3, 4. So that becomes 22.2722. 1, 2, 3, 4. Yep, so it's 22.2722. Positive. So negative 3.86 times negative 5.77 is positive 22.2722. So we multiplied the two numbers, 386 times 577, and we divided each one of those by 100, and that took us to our destination. Very good. Example 5 goes on to another example where you have a positive and a negative multiplying, and the same principle would apply. But let's go ahead and do the unit there, which is 9.23 times negative 0.018. When you have a situation like this, you know your answer is going to be negative at the end of the day, so keep that in mind. But that 923 can be written as 9.23 can be written as 923 over 100. And this one is interesting because now you have a dot here, right? You ask yourself, what is the 8? It's in the thousandths place, right? So that would be times 18 over 1,000, right? So that negative was actually there, but I'm just, let me remove it here. We'll apply it back later. So now you have 923 times 18, right? So 923 times 18 will be the first thing you get. You get 16,614 divided by, you have how many zeros? 1, 2, 3, 4, 5. So that is 5 zeros. So now you ask yourself, and that negative will be there. It becomes negative, and then you count 1, 2, 3, 4, 5. 0.16614. But notice what happened was we multiplied the 923 by the 18, negative 18, and then we put the zeros in the denominator as we needed to, 100 for this one and 1,000 for that one. We multiplied the numerators together, and then we applied that negative, we left it there, and then we moved the decimal points to, depending on how many zeros you have in the denominator. We had 1, 2, 3, 4, 5. So we want 1, let me use a different color, 1, 2, 3, 4, 5. So that's where the decimal point is going to go. And then you put a 0 in front like that, and you are good to go. So that's how we work through that very important skill. Of operations with decimals are the same thing you've learned. PEMDAS is still at work. Now you're just dealing with decimals. So if you have a situation like 2.5a squared minus b squared, and they tell you that a is 3.8 and b is negative 4.6, now you plug in these values, right? So this goes in for a, so that's 2.5 into 3.8 squared minus, and then b squared would be that, negative 4.6 goes in for b. Now we go ahead and use PEMDAS. So we have to take care of the parentheses first. We have to take care of the parentheses and then exponents. The 3.8 squared So it's 3.8 times 3.8. That's 14.44. And we have 2.5 waiting outside minus. And then over here, we have an interesting situation. We have that power waiting there. So that's negative 4.6 times negative 4.6. So we have negative 4.6 times 4, well, 4.6 times 4.6. The negatives are going to cancel. That becomes 21.16. This negative is still there, however. This can also be multiplied at this point. So we have 2.5 times 14.44. So that's 36.1 minus 21.16. Minus 21.16 will take us to our destination. So when you do that, you get 14. So now we have 14.94, because 31.6 minus 21.16 will give us 14.94. So let's take it from the top quickly. We had 2.5 a squared minus b squared. A was 3.8 and b was negative 4.6. We plugged in the value for a. We got 3.8. So 3.8 times 3.8 is 14.44. And then we plugged in this for b. We got negative 4.6 times negative 4.6, and that was positive 21.16. We simplify by multiplying that. We multiply this part, right? We got 31.6, and then 31.6 minus 21.16 takes us to our destination. So that is how we use that principle. Your book goes on to talk about the powers of 10, as I said. When 10, this is just 10 to the first power, and we give you this in our Tools for Mastering Mathematics book. So if you haven't had a chance to read the Tools for Mastering Math book, if you go to the part 2 of the book, that book is available to you for free. It's on our products.toolsformath.com website. On the bottom of the page, toolsformath.org website. If you go to the bottom of the page, you see there's a free copy of the Tools for Mastering Math book. And in the part 2, I explain and share about, the powers of 10. But yeah, the powers of 10 are beautiful. So if you have 10 to the 10th power, you have 10 zeros. Depending on however many, your book gives you an example of 10 to the 6th, which is 1,000,000, right? So it's just good to know the powers of 10 and how it works. Whatever this power is, this exponent will be how many zeros you will have after the 10. And it's good to have an idea of what quantities are in the millions and the billions. So for example, how many, what quantity do you think the stars in the universe are in, 10 to what power? Or what quantity do you think the amount of, money in the stock market is? 10 to what power? Those are just some interesting fun facts to know. So multiplying decimals by powers of 10 is the next section here. When we're multiplying decimals by powers of 10, so if you have 1.527 and you're multiplying that by 10 to the third power, that is 1.527 times 1,000. So then this decimal point will actually move to the right 3 times. 1, 2, 3. So the answer is actually 1,527. So when you're multiplying by a positive power, like 10 to the third power, you move the decimal to the right. When you're multiplying by a negative power, you move the decimal to the left. That's something you're going to learn later on. But if you had a situation like 1.625 times 10 to the negative 1, you would move that decimal over to the left. So it'll become 0.1625. But in this chapter, you're only dealing with it with the positive, and so you move the decimals to the right. Okay, let's talk about 2 key factors of circles, or at least a key factor here. The radius of a circle, right? So we have the radius of a circle. Let's get a circle here. We're going to try and sketch a circle. So the radius of a circle, that's the radius. The diameter would be if we went from one end, went through the center to the other end. That would be the diameter. So for circles, the circumference of a circle is 2 pi r, or pi times d. The area of a circle is pi r squared. So those are formulas that will be good to know. So your book goes on to talk about circles, the radius of the circle, the diameter of a circle, and then I've given you the formula for the circumference of the circle. So you can read the details and just some interesting history on page 378 about pi. And, Archimedes trying to guess the value or trying to estimate the value. There's some work done by the Indians. There's some work done, just different people have given estimates of pi. And so today we say about 3.1419 is a good approximation. A lot of math problems will tell you that pi is, approximately 3.14. The pi is the ratio of the circumference of a circle to its diameter. So if you take the circumference of a circle like I'm doing right now, which is when you go around a circle once, if you take the circumference of a circle and divide it by its diameter, you get pi. Your book gives you digits of pi to 50 digits. There are people who have memorized pi into the hundreds and thousands of digits, but I don't have time to memorize pi that long. And plus, I don't need to know it that long, for that, to 100 or 1,000 digits. But it's fun for some people. But that's not what I choose to do for fun. I do math. I love doing math for fun, but there's another level, which is memorizing pi. So anyways, let me know. What do you think? Should people memorize pi to 1,000 digits? Let me know what you think. So that is the introduction to circles, and then they ask you to find the circumference of a circle. Next to example 9, let's just try a few problems here. So 2 pi r is the formula, and then pi is approximately 3.14. So then it becomes c, and they gave you the radius as 14 inches. So if the radius is 14 inches, you will plug it in 2 times 3.14 times 14, right? So if you're looking for the circumference, basically we know that pi is 3.14 approximately, and we multiply that by 2 and we multiply that by 14. We have 87.92. So that will be the circumference of that circle, 87.92 inches. Sometimes they tell you to leave your answer in terms of pi. In this case, we would literally leave our answer as 28 pi because it would be 2 times 14. Those two things we know, and then we just leave the part that we don't know, pi. We just say 28 pi. So that is an option you might see on some exams. The last section is the area of a circle, which we said is pi r squared. Remember, it's pi r squared. So you must ensure that if they give you the diameter, that you convert to the radius first, or that you get the radius first before you move into the problem more. And so in this case, we basically have, if the diameter was 10 feet and the formula for the area is pi r squared, we change that diameter to the radius, which would be 5 then, and we apply it to the formula pi r squared. So we get 3.14 times 5 times 5. 3.14 times 5 times 5, basically it becomes 3.14 times 25. And that would take you to the answer that you need for this particular problem. So if it's in feet, then you have 3.14 times 25, and that actually is 78.5. So 78.5 feet squared. On the next page, I have a problem here where the radius is 12.2, and you basically plug it into the formula, pi r squared, and you have 3.14 times 12.2 times 12.2, and it gives us this answer as our answer. Let me know if you have any questions. Keep up the good work.